All right, this is day 10, and we are continuing our work on linear programming. Optimization. Linear programming is all about optimization. Optimization means finding the highest or the lowest value of some quantity. Linear programming is the process of optimizing a linear system subject to a system of linear inequalities called constraints. All right, I just want to get you comfortable with the vocabulary here. The graph of a system of constraints is called the feasible region. If an objective function has a maximum or a minimum value, then it must occur at a vertex of the feasible region. Moreover, the objective function will have both a maximum and a minimum value if the feasible region is closed. So that's something to watch out for. There is a such thing as a feasible region that is not closed, and therefore some feasible regions do not have a maximum, or possibly they do not have a minimum. So for example, imagine a system that went like this. So say we had these lines, and say this turned out to be the feasible region in here. See how there's no ceiling here? It could just go up and up and up forever. This system of inequalities would probably have no maximum value. Whereas the usual case is more like this, where, say if this was 1, and this was one of the constraints, and this was one of the constraints, and say the feasible region was in here. See how it's completely closed in? You can be guaranteed that there will be a maximum and a minimum value when the feasible region is closed in like this. But when it's open, there may not be a max or a min. So watch out for that. We will cross that bridge when we come to it, I say. Find the minimum and maximum value of the objective function c equals 3x plus 2y subject to the following constraints. Well, let's take this one at a time and color coordinate like we do. So here's the first inequality. So I have x plus y is less than or equal to 6. We need y to be by itself in order to graph it comfortably. So, okay, so I have this is the inequality that I will actually graph. Start with a plus 6, then I will go down 1, right 1 from there. So it'll be like this. Okay, continue in the other direction. This is going to be a solid line. All of these are solid because it's got the or equal to part. Don't forget, if it does not have the or equal to part, that's when it's dotted. But this one will be solid. So I'm just going to go ahead and graph it up properly. Okay. And also, because this is a less than situation, then we need to shade below this line, and this is the below side, down, down, down. But let's just put a small amount of shading, like fur, on the below side of the line. Okay, in the past, some of you guys have been scribbling like this. Alright, quit it. It's too messy. I can't read it. Alright, just a little bit of fuzz like this from now on, guys. Time to switch colors. Alright, let's go raid. Now, this one is already in slope-intercept form, so let's start with intercept of 2. And then we will go up 1 over 1 from there, like this. Okay. This one is above, so let's go ahead and shade the above side of the line like this. Alright, so far we need to be below the blue line, so that means we're down here, but we need to be above the red line, so far we're in this area right here. Alright, but we have one more inequality to graph, and it is this one. Okay, as I look at this, I imagine the line x equals 0. Alright, x equals a number is always a vertical line, straight up and down. So this particular vertical line is the y-axis. Alright, so here is that vertical line, x equals 0. And this says greater than. Normally we do above and below, but a vertical line is the one time that we do left and right. X values are greater to the right, so that means we will shade on the right hand side of this line. Alright, I know that purple one's a little hard to see because it is right on the axis. Maybe we can zoom in. Alright, because it's time to see where the feasible region is. Hopefully you can see that this little triangle here is going to be the feasible region. It's the area that satisfies all 3 inequalities. So let me see if I can draw this thing real quick. Okay, so this is the feasible region right here. What shall we color it? Yellow, perhaps. Alright, that yellow area is the feasible region. Now, we're going to need the vertices of it. So I have a vertex here, here, and here. So I have one vertex at 0, 2. I have another one at 0, 6, and I have another vertex at 2, 4. Alright, those are the 3 vertices. So if I want to find the maximum and minimum, I'm guaranteed that they will be at one of these 3 values. Well, the objective function is c equals 3x plus 2y. So let's just substitute these in one at a time and see what happens. So let's start with 0, 2. That'll give us 3 times 0 plus 2 times 2, which is 4. And then we'll do 0, 6. So that's 3 times 0 plus 2 times 6, which is 12. And then finally 2, 4. 3 times 2 plus 2 times 4. Alright, well that's 6 plus 8, which is 14. So you can see we have a maximum value of 14, which comes from this point. And we'll have our minimum value of 4 coming from this point. It might be too dark to see through later. So the way you record your final answer is like this. You say max equals 14 and that came from the point 2, 4. The minimum equals 4 at the point 0, 2. So that's just a nice compact way to summarize everything we found out. Okay, so that was problem number 1. Let's take a look at problem number 2. Alright, well, we've got all these little constraints. Let's zoom in a bit. Alright, let's start with this equation. This is just like having x equals 1 as far as what we're going to graph first. And remember, that is a vertical line. So that's going to be a vertical line right here at 1. Alright, so there's the vertical line at 1. Now, this is greater than 1, and remember, with these vertical lines, this is the only time that we shade left or right. Greater than will be to the right. So we're going to shade on the right hand side of this line. Please, no more scribbles, guys. This is how I want you to shade that initial amount. Now let's do the next one in red. Alright, it's another vertical line, and so a vertical line at 4 this time, just like this. Now this one is less than, so we will shade on the left hand side. So we're just going to put a little bit of fur on the left hand side to remind us. That's just so we don't have to keep looking back and forth and trying to remember now which side of the line and which one was it. We just put the little fur on there right when we first graph it, and then we don't have to remember. We can tell at a glance. Just trust me, it's a way to stay organized. Now we'll do a purple one. Okay, these are horizontal lines. Like y equals 0 is a horizontal line at 0. So guess what? That's the x-axis. And when we shade, we're going to shade above because y's go up and down, and this is greater than. Greater, we shade above. So let's go ahead and draw that. Alright, so there's my little purple line, and we will shade above as promised. Okay, so far that puts us in this area right here, to the right of the blue, to the left of the red, and above the purple. But there's one more inequality left, and it is this green one. Alright, so this is another horizontal line. Y equals 9 is going to be a horizontal line right across here. And this one says less than, so we're going to shade below. Alright, just a little bit of fur on the below side of the line, just enough to remember. So that puts us inside the box here in terms of our feasible region. So let's just shade the box. Okay, so this is our feasible region right here. And what we really need are the vertices. And so the vertices are here, 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 and here. So we have one vertex here at that's 1, 9. We have another vertex here at 4, 9. We have a vertex here at 4, 0. And we have a vertex here at 1, 0. So those are our 4 vertices. Now let's remember what the objective function was, if I can find it. Where are you, objective function? Oh, we're supposed to use the same one over and over again. Okay, so we're still using 3x plus 2y. I see how it is. We'll use this space over here to the left, I suppose. Should I go underneath or left? I'll do left. So here's our objective function again. So c equals 2x plus 3y. Is that what it was? Oh, I have it backwards. Phew, I'm glad I checked. 3x plus 2y. Yeah. Okay, so I better fix that. Alright, that's better. So let's just go around the clock with our vertices. So we're going to have 1, 0. So that'll give us this. And then we will do 1, 9. Alright, so that's 21. And then we'll go over to 4, 9. And that's 30. And finally we have 4, 0. And that is 12. Alrighty then. So we can see that we have our minimum value. I think I had decided that was too dark. Let's try this one. We had our minimum value of 3, which came from this point right here. And we had our maximum value of 30, which came from this point right here. So, time to record our final answer like we do. And we do it like this. We say max equals 30 at the point 4, 9. And we say min equals 3 at the point 1, 0. Alright, that is problem number 2. I think we just have one more of these, I do believe, and we're done. Sort of a short little lesson. Only 3 real problems, but what are you going to do? It's enough already. So let's get back to this final problem. This equation is going to need to be rewritten. So let's do that over here. If I've got x plus y is less than or equal to 10, we just need to subtract x from both sides. So that's going to give me y is less than or equal to negative x plus 10. So starting up here at 10, and then this will be like negative 1 over 1. So that means down 1, right 1. Always go to the right. So that'll be like this. So let's go ahead and draw this line. There's the first line, and we're going to be less than or equal to this line, which means we need a shade below the line, like this. No scribbles, please. Just a little bit of fur is all you need. Now let's switch over to red for the next one. Please understand that we're starting with x equals 0. This is a vertical line. So it's the y-axis. And it is greater than So that means I'm going to go ahead and shade to the right. Please remember that a vertical line is the only time we do left and right. Usually it's above and below. So greater than for x's will be to the right. So I'll just put a little bit of fur. I'm not going to go crazy with a whole bunch of scribbles all over the place, making it impossible for Mr. Burton to grade accurately. Alright, I'm just going to put just enough to remind me which side of the line the feasible region must be on. And let's see, let's go to our good friend Mr. Purple and do this right here. So right now we've got x minus y is less than or equal to 0. Got to get that y by itself. Checking out this negative sign right in front of the y. I know I'm going to have to wind up reversing later. That's a v, by the way, reverse. So I'm going to have to subtract x from both sides. So that's going to give me negative y is less than or equal to negative x so far. But you can't leave a negative sign in front of the y like that. That's not copacetic. So what we have to do is divide everything by negative 1. Some kids like to think of it as multiplying by negative 1. Same thing. So we're going to wind up with y is greater than or equal to x. Okay, please remember that when you multiply or divide by a negative number, it reverses the direction of the inequality. Now, some kids mistakenly think that this is going to be either a vertical line or a horizontal line. It is neither. This is a diagonal line. When I help kids understand this, I always ask them, look, if I asked you to graph the line y equals x plus 3, what would you do? And they always say, oh, I'd go up to 3 on the y-axis because of that, and then I'd go like up 1 over 1, like that. Well, if you understand that, then you can understand that if I take away the 3, I'm still going up 1 over 1, okay? It's just that instead of starting at 3, where am I starting? 0. I'm starting at the origin. Okay, so basically this is just like plus 0. So we start off at 0, comma 0, and then we use the slope, up 1 over 1. So you see this is a diagonal line, not a vertical line, not a horizontal line. Alright, we'll just draw this line. Alright, and that line's going to look just like that. Now, remember, this was greater than, once we reversed it, this is greater than, which means we are going to shade above the line. Okay, up, 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 above. So as we put a little bit of fur on the above side of the line, it becomes clear that the feasible region is this triangle right here. So let's shade it in. Alright, so this will be the feasible region. As you can see, we have 3 vertices. One of the vertices is the origin, 0, 0. Another vertex is way up here, that is 0, 10. And a third vertex is here at 5, 5. So these are the vertices that we must put into our objective function and see what happens. Now I'm going to have to do it down here because I don't have a lot of space. If I recall correctly, our objective function was 3x plus 2y. So starting with the one that we know is not going to be, well, it could be the minimum. 3, 0, 2, 0 equals 0. So then I have 0, 10. which gives me 3 comma 0 plus 2 times 10, and that's 20. And then finally 5, 5. 5 comma 5. So that makes it 3 comma 5. Why do I keep saying comma? 3 times 5 and 2 times 5. I just got comma on the brain. And so look, that's going to be 15 plus 10, so that's 25. Alrighty then. We have our max and min. Our maximum value is 25, coming from this point right here. Our minimum value, let me see if purple will work. Oh, that's pretty dark. It's pretty dark, man. But you know, I'm gonna deal with it right. So time for the final answer. Our maximum was 25 at 5 comma 5, and our minimum equals 0 at 0 comma 0. There you go. That is the end of this little lesson. I hope you learned a little something, and I will see you on the next video.